so first thing we're going to do is we are going to be practicing using the log button in our calculator. I'm going to show you guys how to use that. So if you take a look at the log button in your calculator, what base is it? Is there a base written on the button? No. So what did I tell you? If there's no base written, it's always what?
Base 10.
Base 10. So this log button in your calculator can only do a base 10. So if you're given problems like this and you're told to evaluate it, you can just go ahead and use your calculator to do it. So figure out log 10, and you just type in log and then 10. Log 10 is 1. Go ahead, figure out the other 3. What's the log of 0.001? What do we get? Negative 3.
You know how you were telling me to do stats and clear calculation?
All right, so it's log of 1.
How many decimals are we going to?
Did we do log of 1 yet?
Yes.
0.
We're going to the nearest 10,000th, which would be 4 numbers after the decimal for our last one. So it's what?
2.6675.
There we go. So that's how we evaluate, and they will tell you specifically that you need to evaluate them, so you know you need to use your calculator. Same thing works, though, if they tell you to do the ln. You still just use your calculator button there. So to find the ln of e, we would push our ln button. But then we have to do second ln to get the e. And what should we put in the exponent spot? A 1, because if you look at our problem here, this is just e, so which means it's really e to the first. We just don't always tell you that 1's there, but it is. So what do we get? 1. So go ahead, figure out the other 2. Type in ln and then 5. And we're going to the nearest 10,000th again. So ln of 5, what do we get? 1.6094. And then the ln of 1? You just push the ln button, it's under log, and then you would push the number 5. So here's ln, and then 5. Now the last one, as we said, the calculator, that log button only does what base? 10. So if we look at our first example, we have log base 2 of 8. Now there's a couple ways of doing this. One way is you can sit there and ask yourself, 2 to what power gives me an 8? 3. But does that work for 3 to get you a 5? No, it doesn't always work that way. So if you have one of the newer calculators, they added this great function into it. If you push math, and then you want to arrow up, it gives you what's called log base. This allows you to do any base now. So if we want to do log base 3 of 5, to the nearest 10,000th, what do we get? Then you would just have to leave it. Or borrow one of mine calculators.
Wait, what? What did you say?
All right, so let's have you go ahead and do the next one. So math, go to the log base. You add a base of 5 of 0.3. What do we get? Negative point what?
Negative 0.7408.
Pretty sure it was 8.1. Now, other options you have, there are also online calculators. You can just go to Google, type in online graphing calculator. A lot of them can do this function also if you don't have one at home. Or you're always welcome to borrow them after school. They just can't go home with you. Taking a look at the back of our notes today. These are pretty easy once you get to the hang of it, but it's getting the hang of it that you got to do first. So first thing we have to remember is that log equals your exponent. Bless you. So what we're going to be doing is sometimes they ask you to take a log problem and they want you to be able to expand it out. And then they have you go the other way sometimes. They give you a nice long expanded one. They want you to condense it down into one log term. So in order to do that, you have to follow your log properties. So since logs are just basically your exponents, when it comes to the product rule, which means our multiplication, you have to think back to your exponents. Let's say I had x to the 7th times x to the 5th. What do we do with our exponents there?
Add them.
Add them. And we would get x to the 12th. Same thing happens with your logs. If you are multiplying two things, that really means you want to add their logs together. It's the same as your exponents because your logs are your exponents. So if you're multiplying them, that really means you're adding your two logs together. Quotient rule. So if we're dividing, what do we do with our exponents? Subtract them. So we get x to the 8th. Same thing happens with our logs. If I'm dividing them, that means I'm really subtracting their two separate logs. The power rule. So let's say I have x to the 3rd to the 4th power, our power to a power. What would we do with our exponents there? Multiply them. So we would get x to the 12th. Again, we're doing the same thing with our logs, but what they do is they take the exponent and they put it in front of the word log, like we have written over here. So it becomes p times the log of m. So you're still multiplying them just like you would with your exponent to exponent. And then the equality of logs, we're going to get this a little bit more in the next couple of days. If you have log m equals the log of n, you just drop the logs and the two letters are equal to each other as long as the logs are the same. But as I said, we're going to deal with that one a little bit more in a couple of days. We're focusing right now pretty much on these top three. So, as I said, they ask you to do two things. They ask you to expand and they ask you to condense. So when we are expanding, you want to first deal with any quotients. So if there's any division, you take care of those ones first. You then deal with any products. And the last are your exponents. So quotients, products, and then exponents. So let's take a look at our first example. We have log base 5 of 2x divided by y to the 3rd. So do we have a quotient there? Yeah, we have 2x is divided by y to the 3rd. So I'm going to take care of that first by writing log base 5 of my numerator, so my 2x. And then I'm going to subtract log base 5 of my denominator. So when we're expanding, we're adding more logs in there. We're adding that word more often. So the next thing we look for, do we have any products, anything being multiplied? Yes. We don't say it, but we have 2 times x there. We just say it as 2x, but really what we're doing is we're doing 2 times the x. So we need to separate those by adding them. So log base 5 of 2 plus log base 5 of x, and still minus your log base 5 of y to the 3rd. So we've separated our quotient, taken care of our products. Do we have any exponents? Yep, we got this one here. We've got to bring it down in front. So our final answer is log base 5 of 2 plus my log base 5 of x. And then it's minus 3 log base 5 of y. That is our expanded form. So it's really not that bad as long as you make sure you go step by step by step through them. for our next example, we have 10 square root of a all over bc. But what we have to do is anytime we have a radical, we have to rewrite that as our fraction exponent. So if I'm taking the square root of a, how would I write that as an exponent? Not squared. To 1/2. So what you want to do is you kind of want to change that so that it's your fraction exponent as to oppose your radical first. So 10 times a to the 1/2 all over bc. So now we'll follow our steps over there. Do we have any quotients, anything being divided? Yes. So we got to take care of that first. So log 10a to the 1/2 minus log bc. So the quotient minus the denominator, or the numerator minus the denominator. So next one would be our products. We actually have 2 of them this time. So we're going to do log 10 plus log a to the 1/2. And then it's minus, and we have to put parentheses around our log b plus log c. Because that entire thing is in the denominator. Both the b and the c is in the denominator. So you got to put parentheses around it and then subtract them so that you can remember you're subtracting both of them. If you don't have that parenthesis, it's a very different problem. Okay. Do we have any exponents now? Yep, so we got to take care of that. So log 10 plus 1/2 log a minus parentheses log b plus log c. So we have one more thing we have to do here. They weren't specifically written in the directions, but it's just one little thing. If you have the log of a number like this one, log 10, you want to see if that's going to be a whole number in your calculator. So let's have you type in your calculator log 10. This one's a base 10 already, so we can just use the log button. What do we get? A 1. So whenever it turns into a whole number like that, you have to clean it up. It's a kind of an unwritten rule for your logs. So instead of log 10, it turns into 1 plus your 1/2 log a. Now you can distribute your negative sign through and write log b minus log c. Or you could still leave it in the parentheses. Either of those are fine at that point in time. So now just to go over again what we did with our log 10, turning that into a 1, we didn't do it in this first problem because if we tried to do log base 5 of 2, we would get a decimal, and we don't want to use the decimal. It's only when it works out to be a whole number that we want to use it. Does that make sense? Okay. So as I was saying, the other thing they tell us to do is they tell us to condense it down sometimes. So when we condense, it's actually going to be the opposite of your steps for that one. So instead of exponents last, when you're condensing, you're going to take care of your exponents first. Your products would be second. And then your quotients would be last. So take a look at our first example here. I know I have 2 exponents because I have numbers in front of the log. So whenever you have numbers in the front, those are always exponents. So this is going to turn into log of a to the 1/2 minus the log of c to the 4th. I take those numbers in the front and I put them back as my exponents. So now the fact that these are being subtracted means what's actually happening with my a and my c. Are we multiplying them? Are we dividing them? What are we doing? Dividing. So we're just going to write 1 log a to the 1/2 over c to the 4th. And then that's going to be our final answer there. When you're condensing, the goal is to write log only once. So you keep going until you only have it written once. All right, so let's take a look at our second example under condensing. So again, I've got a number out in front here. I got this 3, so that tells me that's an exponent. I'm going to take care of that first. So log base 2 of z to the third. And then I'm just going to keep rewriting the other stuff after it. So I got my log base 2 of 4x minus 3 minus my log base 2 of x. So next we have our products, which would be my z to the third and my 4x minus 3, since their logs are added together. So log 2 of z to the third, parentheses 4x minus 3, minus my log base 2 of x. And then last step would be our quotient. So I have log base 2 of z to the third times 4x minus 3 all over x. That's our final answer there. So as I said, it's really not bad once you keep getting in the habit of it. You remember quotient means to subtract them, product means you're multiplying them, exponents go in front.